Find the slope of a line on a coordinate grid using slope triangles. So today we're going to be given a line that we're going to see on a graph, and we're just going to be asked to find the slope of that line. Now you guys should already know what slope of a line is. So somebody who remembers from last year, what is slope? When we're talking about slope of a line, what are we talking about? Andrew.
Oh.
The angle of the line or the steepness of the line. I like both of those descriptions. The angle of the line. Angle or steepness of the line means the same thing. Last year you probably learned a pseudo-math equation. Pseudo-math means it's kind of math. It's got some math symbols in there, but it also might have some words in there. So engineers, mathematicians, they'll use pseudo-math a lot to kind of describe things before they're quite ready to really make an equation out of it. So last year you probably learned that slope was equal to something. What is slope equal to? Anybody remember anything like this?
Summer killed it.
Isaiah.
Ratio.
Ratio.
Yes.
Kind of. We're actually going to get to that later in the year. You might have learned that. I don't know. Not quite what I was looking for today, though. Ricardo.
Line.
All right. Slope is equal to rise over run.
Oh, yeah.
So we describe the slope of a line by relating how much it goes up and down with how much it runs, how much it goes forward and backwards. Huh? Okay, so we're looking at slope is equal to the rise over the run. In other words, that's describing how much it goes up and down in relation to how much it goes forward and backward. So when we're trying to find the slope of a line, we may have a line that looks like this. And we'll be asked to find the slope of the line. Now we want to describe that slope of the line in terms of the difference in its rise over run. And the way that we're going to do that is we're going to pick 2 points where it goes through a point, and I can see one here.
Thank you.
And I can see one here. So this is where we're going to draw a slope triangle. And the way that slope triangle works is it's just basically how we would walk along the grid lines to get from one point to the next. So my slope triangle I'm going to here is in red. I'm going to kind of walk along this path. I'm going to move up. And then I'm going to move forward to get to my point. Now, anytime that we move up, that's a description of a rise that is positive. That's a positive rise. If you're going up, that's positive. That makes sense. Anytime we are moving forward, that is described as a positive run. That makes sense. You're moving forward. That's a good thing. That's positive. So here, if we use our pseudo equation, slope is equal to rise over run.
Okay.
We would find that the slope of this equation is positive 2 because we went up, and a run of positive 3. Slope is equal to rise over run. Now we see this slope of this line has a positive slope, 2 over 3. Now one thing that we do want to recognize and that you do need to know is it doesn't matter where you pick on the line, what point you pick on the line. I could have picked this point, and this point. And what I'm still going to see is no matter where I measure on the line, I still have a rise of 2 and a run of 3. Or we could even pick 2 points that seem totally far away from each other. I can pick this point and this point. And if I rise, I'm going to rise 1, 2, 3, 4, 5, 6. And run 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have a rise of 6 and a run of 9. So if I were to write my rise over run, I have 6 over 9. Is that the same thing? Think carefully. Yes, what do I need to do? Simplify. Divide by 3 over 3, and I get 2/3. So one very important point is it doesn't matter where you are on the line, what points you pick, slope is always going to be the same. They love to ask this question on the CST. They will give you 3 points just like this. Just like this. They'll be like, all right, this is A, this is B, and this is C. And they'll say, what is the relationship between the slope between A and B and B and C? No matter where you are on the line, the slope is always the same. So the slope from A to B is the same as the slope from B to C. It seems like such a tricky question when you read it, but it's asking you is, hey, no matter where you are on the line, is the slope always the same?
Yes.
Absolutely. All right. Now, we noticed that this blue line, we came out with a positive 2/3. So we know this is a positively sloped line. One way we're going to be able to recognize positively sloped lines before we even start doing any work is all positively sloped lines are going to end going upward. If they are pointing upward at the end, they are a positively sloped line. Now, the next line I am about to graph, I'm going to do so in orange. Give me a second. I want to get a nice perfect line for us to be able to find slope with. Okay. This particular line, we see ends going downward. So we would expect the slope of this line to be negative. Negatively sloped lines always end going downward. So I'm going to pick 2 points on this line. I see one here. And I actually see another one right there. And I'm going to find the slope of this line. So I'm figuring out, well, how am I going to walk from one point to the next? So I am going down. Now, if I'm going down, do you think that rise is positive or negative? Negative. So anytime I'm going down to get to my point, that's going to be a negative rise. So my rise is -1. Then I'm going to move forward 1, 2. If I'm moving forward, is that a positive or a negative run? Positive. If we're moving forward, that's positive. So as I come to my equation, slope equals rise over run. And so we go back to what we labeled. We labeled our rise over here was -1. And our run, we labeled over here, was +2. So we get 1 over -2. Sure enough, -1 over 2, that's a bad date, that's negative. And so we get that negative slope, just like we expected. There are 2 special cases that you need to know about. I'm going to graph one of them in this chocolate brown color. Yum, delicious. So I have this line over here. This line is horizontal. This line we call as having zero slope.
I remember that line.
We know that that line has zero slope. The way I like to think about it, I like to think about this as a skier sitting on this slope, because sometimes they call ski slopes slopes. Hence, they call them ski slopes. All right. So if the skier is sitting on this line, he's not going anywhere. He's going to have zero movement because is he going to be sliding downhill or uphill? No. So that's how I remember that it has zero slope. Now, I'm in this little purple color. This is a vertical line. This line does not have zero slope, and that's the common misconception. The reason it doesn't have zero slope is because if you thought about the way it would work with rise over run, the run would be zero. Mathematically, anytime we divide by zero, we call that being undefined. And you'll learn a little bit more about that and some more specifics as to why when you get a little bit further on in your math career. So we call this slope as being undefined. Now, the way that I like to remember this is thinking about my same skier. If I put my same skier on this slope, he will be in a free fall. And when he gets to the bottom, he will no longer be defined as human being. He will be defined as splatter on floor. So that's how I like to remember the difference between a zero slope and an undefined slope. Zero slope, skier, just not going to be going anywhere. Undefined slope, he's going to be going somewhere straight to the ground where he will splatter and no longer be defined as human. Undefined. Yes, ma'am?
So, like, if you did a zero slope thing on your grid, is that because there's something like
So you're going to learn later on how to graph very specific equations that have zero slope or undefined slope. But at this point, if we graph anything that I'm giving you to graph right now, if it has a zero slope or an undefined slope, that's going to be a problem. Okay, because you're going to know exactly what zero and undefined slopes look like by the end of the unit. Yes, sir?
You made it kind of confusing when you said when it's going down, it's going to be negative. Because, like, shouldn't you only say if it's going down rightward? Because if it's going down leftward, it's going to automatically be positive.
Yeah, so Isaiah's making a good clarification here. He's saying when I'm talking about it going upward, I'm talking about it ending going upward. And I always think ending going in the positive direction, going forward. So this one, as I go forward, it ends going down. Okay, so that's definitely a good clarification. All right, so now that we know what a positively sloped line, a negatively sloped line, an undefined slope line, and a zero slope line look like, we can use those ideas the second we see a line like this one to help determine something we know about this line. So we know when we find the value of the slope for this line, the value is going to be positive or negative? Positive, because we see here that it ends kind of going upward. So the first thing that we're going to write whenever we see a problem like this and you're asked to find the slope of the line, you're going to write whether it's a positively sloped line, negatively sloped line, or if it just so happens to be undefined or zero. So this one's a positively sloped line. The reason we're writing this is because at the end, if for some reason we don't get a positive value, that will tell us that something is wrong. And that is something that the reason why the other two classes don't have really perfect mastery is because a lot of them aren't checking at the end. They would write the word positive, and then they would write something in their answer. They would write, oh, -1/2. And they would go like that. If you write positive, this number that you box in better be positive. That just makes sense.
Yeah.
All right. So in order to actually find the value of the slope, we want to pick 2 points where it goes right through the corner. So I'm going to zoom in here really quickly. It looks like it goes right through the corner here. And it looks like it probably goes right through the corner here. So I'm going to calculate my rise and my run by drawing a slope triangle. So I'm rising up. If I'm rising up, is that rise positive or negative?
Positive.
Positive. So I'm going to write a positive 2. And I'm running forward from there.
Oh.
Is that run positive or negative?
Positive.
For running forward, that's positive. So we're going to go ahead and write our equation really quickly over here. Slope is equal to
Slope.
rise over run. Our rise was 2, and our run was 4. Now, is this a complete and final answer?
No.
Absolutely not, because this is not simplified. So we're going to divide by 2 over 2. That's going to give me 1/2. And before I box this in, I'm going to say, okay, 1/2 is positive. I said this was supposed to be the positive. That's good. I'm happy with that.
Yeah.
Mr. Ross.
Why change it from 2/4 if it means just
Oh my god.
Because anytime we talk in math, we want to talk in most simplified terms. All right. Next one. Looking at this line, before I even start, I know that the slope of this line is positive or negative.
Positive. I mean negative.
Again, we're looking at how it ends. It ends going down. So this means that the slope of this line is definitely going to be negative. I'm going to zoom in here. I'm going to find a couple points where it looks like it goes right through the corners.
That -1, -5.
I hear him saying -1, -5. That's over here. That's not right.
Where are we going?
Right there.
Maybe right here.
-4.
No, -1.
This one looks good.
Yeah.
And I guess he's saying this one looks
Yeah.
good as well.
There.
Okay. So I'm going to check my rise.
Oh my gosh.
My rise is going down. Does that mean my rise is positive or negative?
Negative.
Negative. So this is a rise of -1, 2, 3. And my run from there is forward, so my run is positive or negative?
Negative.
My run is forward. Is that positive or negative?
Positive.
Positive.
-1.
Doesn't matter where it ends, it matters how you get there.
Yes.
So slope is equal to rise over run. My rise over here we wrote was -3,
Yes.
and my run was +2.
I'll write it down.
Andrea. So on these particular lines that I've drawn for you today, it can be kind of confusing because I could see how you would think that this point also went right through the center. On the lines that I give you on your test, it's going to be very clear where they go through the corners, or I will have picked one for you. So I would accept your answer because I can understand why you would choose those 2 points. Can both of those answers in the real world be correct, though?
Yes.
No, because the slope on any line must be the same no matter where you choose it from, okay? So this is that's just a small problem that we have with what we can see. Now, I recognize here that I got an answer that was negative. Should my answer have been negative?
Yes.
Yeah, we wrote so right at the beginning. Question, Oscar. Oh, Oscar's stretching, and he's raising his hand so he can tell me, is the slope of this line positive or negative? Negative. We see that it's ending going down. So I want to zoom in and I want to pick a couple points. This one definitely looks really obvious to me over here at 2, -2. And this one looks pretty good to me over here at 6, -3.
-6, 0.
So I'm going to draw my slope triangle. In my slope triangle, my rise is going down. Does that make my rise positive or negative? Negative. So it's a rise of -1. My run is 1, 2, 3, 4. Forward. Is my run positive or negative?
Positive.
Positive. Forward is a positive run. So here I am again. I'm writing slope equals
-1/4.
rise over run. Making sure you get those numbers in the right place. Rise is -1. Run is 4. A couple people who didn't show mastery today flipped their rise and their run when they wrote it in their equation. Something as simple as that is going to cause you to get problems completely wrong. Now, I got a negative answer. Was my answer supposed to be negative?
Yes.
Absolutely. We wrote up here negative. Okay? I'm not going to do the last problem because I think at this point that we understand what's going on. Looking at our key points for today, key point number 1 is this equation. Slope equals rise over 1. That's kind of a key point for the entire unit. And the other key point that I would like, we'll do triangle in a box, is the labeling of all of these different types of graphs as positive, negative, 0, and undefined.
Where?
All right. So I want you to move on to your together time. There are only 4 problems on your together time. That really should not take you more than 3.5 minutes. You must always, as part of your work, until this unit is over, always write slope equals rise over run.
It's more work. No.
Kevin, I would be pleased if you flipped over and started doing your work. I would be pleased if you started doing your work.
I would